In this video, we're going to discuss CRA models for whole number subtraction. So it's going to be similar to addition. We have two different types of models. The first type that we're going to look at is going to be a set model. So again, that's where we're not measuring any dimensions. So it's a zero-dimensional measurement, and all we're looking at then is with the frequency or the count of objects. So the first one we'll look at is going to be a example for younger students. We're going to use the 10 frames and then these two color counters. So you'll notice that we only have one quantity that's presented right at the start. Whereas with addition, we had two quantities and we're going to combine them. We're going to add them together into one larger quantity. Since subtraction is the inverse operation, we're doing the opposite action. All right. So with addition, we're starting with two smaller ones, combining them into one larger one. With subtraction, we're starting with this larger group, and we're going to subtract or take away some portion, which will leave two smaller groups. Okay, so for this, I just have 16 modeled right now. The problem that we're going to be doing is 16 minus 7. So again, one of the main schemas is to conceptualize subtraction as taking away. So from this group of 16, we're going to take away 7 counters. So if you wanted, you could flip them over. I'm just going to remove them just to kind of highlight this idea that we're removing these 7 counters from this group of 16. So we can just do this one at a time. So 5, 6. So I've removed 7 counters from that original group, which has left me with 9. So if I do 16 and then take away or subtract 7, it will leave me with 9. So the difference is going to be 9 here. Okay. So that's our concrete model. A representational model, right? Some kind of image or drawing. So I just drew these counters or just these circles. So again, with the representational model, so we're still going to do the 16 minus 7. Whether it's a picture or a drawing, right? If it's a drawing on a whiteboard, we could erase 7. That might make it a little harder to keep track of. So usually crossing them out is going to be an easy strategy, just so we can make sure that we did actually subtract 7 from this group. So we're going to start with 16. We're going to remove 7. If you wanted, you could redraw them somewhere else, but if we just cross these off one at a time, we'll still be able to track how many we've removed or subtracted. 2, 3, 4, 5, 6, and 7. Okay, so I started with 16. I subtracted 7, which leaves me with 9. And then our abstract model for this will just be 16 minus 7 is equal to 9. And then we'll look at another example for the set model. And this will be one that kind of shows this idea that we're going to be applying in our standard algorithms, which we'll get to later on, which is this idea of regrouping. Okay. So again, here I just have one quantity that's actually shown, right? Since I'm doing subtraction, I'm going to take some amount away from this. So here I have 6 10s and I have 3 1s. So I have 63. I'll write this here just so we can see what we're... And I'm going to subtract 14. Okay, so 63 minus 14 is what we're looking at here. So we're going to start with our ones column. Again, for subtraction, I'm just going to move these just off, but just slightly below our place value mat. So we're going to take the base 10 blocks and put them down here. So we can just still see and track and make sure we've actually removed 14. So here, if I'm subtracting 14, that means I need to take away 4 1s. But I only have 3 1s. So what I need to do in this case is regroup or ungroup one of these 10s and turn that into 10 1s. Okay. So again, it's just the opposite action that we did with addition for subtraction. So we're going to take one of these 10s. We're going to ungroup this. Okay, because this is a solid object, we're going to ungroup this into 10 1s. And again, since these are now 1s, they need to be in the 1s place value. Okay. Okay, so I haven't changed my original quantity. I've just regrouped this to make it so that I can actually take away 4 ones. Okay, so again, I need to take 4 ones away. And if you want to, we can rearrange these just to more easily see what we have remaining in that ones column. Okay, so I've taken away my 4 ones. I need to take away 14, so I still need to take away 110. So I'll take that 110 away. So then what I'm left with, right, I have 4 10s and I have 9 1s, so I'm left with 49. So our difference is going to be 49. Okay, so that's a concrete model. So then we'll look at a representational model, that same example. So again, I'll write the problem up here just so we can kind of keep track of what we're doing. So we'll do 63 minus 14. Okay, so again, we just have kind of a drawing of those base 10 blocks. So we have 6 10s, we have 3 1s, we want to take away 14. So what we need to do first is we need to take this, right? We can't take away 4 1s because we don't have 4 1s, we don't have enough. So we're going to take one of these 10s, right, and we're going to ungroup this into 10 1s. Okay, I'm going to actually redraw this just so we can more easily see what we actually have here, because I'm going to start crossing some of these out. So I still have those 5 10s, and then here I have, so there's my 10, and I'll just do the 3 over here. And I have those 13 1s. Okay. So again, I'm just going to cross these off. So I'm going to cross off 4 1s because I need to take away 4 1s. Cross that one off, that one, that one, that one. So there's 4 1s that are crossed off. And I need to take away one of these 10s, so I'm going to cross that one off too. Do extra over that one. Okay. So then what am I left with? I have 4 10s and I have 9 1s, so I'm left with 49. And then for our abstract model, right, we'll get to the standard algorithms later that kind of better highlight some of these, some of the moves that are actually happening in these models. This would be 63 minus 14 is equal to 49. All right, so that was another set model, and then we'll look at our other type of model that we can use for subtraction, which is going to be similar to addition, which is our length model. So again, this is a one-dimensional model, so we're measuring the actual length. We're not just counting the objects, we're measuring the length of them. So for the concrete model, we're going to go back to that 16 minus 7 example that we did, and I just have some connecting cubes here. Okay, so I have 16 connecting cubes that are there, and again, we're just starting with that one quantity that's modeled, and we want to take away that quantity of 7. Okay, so we could go one by one if we wanted, or we can just count up to 7. Okay, so I had that original length of 16. I subtracted or took 7 away, so then I'm looking at what is the length of what I have remaining. Right, so I have a length of 9. Okay, so 16 minus 7 leaves us with that length of 9. Okay. So the connecting cubes, that was our concrete model. For our representational model, again, a common representational model for length is going to be our number line. So we're starting at 16. And we want to take away 7, right? So if we're adding, right, we always move to the right side of the number line. Right, we're moving to the right. Since this is the inverse or opposite operation, we're moving to the opposite direction, so we're moving to the left. Okay. So if we wanted, right, for a simpler version, if we just count by ones, we're counting backwards, we're subtracting 1 at a time. So it's 1, 2, 3, 4, 5, 6, and then 7. So I've subtracted 7 from that total starting length of 16. So I've taken 7 away. So I'm left with this length of 9. And our abstract model for this one is just going to be 16 minus 7 is equal to 9. So again, for whole number subtraction, again, set models and length models are going to be the two types of models that we use. And for the set models, just any kind of physical objects, so based on blocks, counters, candy, toys, things like that. And then for length model, those connecting cubes and number lines are going to be common options for those.